Hello everyone, thank you for joining us today in this webinar for exploring the new IoT stack for DreamFactory. Just a few housekeeping rules before we get started. Everybody is muted and I ask that you please remain so throughout the webinar. You are definitely encouraged to ask questions, so to do so please post in the chat window, and at the end of the session there will be a dedicated Q&A. The webinar will be recorded and is being recorded right now, and after it's done we'll make sure it's available after just a few days after editing. And if we don't get to your question, please include your email so we can follow up with you after the webinar is over. Great. Let's get started. I'm Alex. I'm playing the role of host for this webinar today. I'm head of developer relations and community here at DreamFactory Software. And also with us is John Akiram. He's an analyst advisor and an architect at John Akiram and Associates. So before I pass this over to him, I'm just going to do a quick overview of DreamFactory. So DreamFactory is an open source API platform for mobile, web, and IoT applications. You can think of us as a middleware. We make it really easy for you to build your applications without a ton of code, and that's what we like to call API automation. So DreamFactory instantly turns any database you have into an API platform, and as a developer you get instant APIs to your data without using code. But don't worry, we support server-side scripting with JavaScript, Node.js, and PHP, and we've also got a built-in security features including user management, authentication, OAuth, and Active Directory. DreamFactory is written on a Laravel framework, V8 engine, and PHP 7. So let me just break this down a little bit. The DreamFactory platform can be installed on almost any server. Here are some of the popular environments where you can install DreamFactory. DreamFactory can be used to connect to any data source. We do an especially good job exposing legacy, Oracle, and DB2 instances and exposing all of that data through our RESTful API. And DreamFactory can be used to develop for almost any device. Native application environments like iOS and Android. And pictured there, you can see some of our popular developer environments that we support and generate client SDKs for. So this API automation approach that DreamFactory does, in contrast to manually building APIs, is quite different. The key is that it's all about reusable APIs. It lets you focus instead of more than half your time on back-end integration. What it does is it really lets your team focus on the front-end app development, which frees up a ton of time to focus on your user experience and the actual thing you're building and not the plumbing under the hood. So it lets you decouple your client side from your server side, so it mitigates that interface negotiation. It lets you also hook up to really any backend infrastructure, so it's super portable in the sense that you can use different databases very easily. So this decoupling effect lets you write the same application that will work the same with any backend database or infrastructure. The documentation for your API should be automatically documented. That's key. And we do this automatically. And the idea of manually writing APIs is just a very old idea. And lastly, API automation gives you all the great benefits of clean software development and reusability, the byproduct of which is really a great scalable system that's reliable, portable, and highly secure. So to quickly recap, this is a picture with all the manual APIs. You waste a lot of time in the backend integration. It's very complex. It's generally not very secure. It's not portable, so it's hard to develop, test, and production across your whole suite of apps. And building new REST APIs for each project is just a bad idea. And this is a problem that DreamFactory solves. And this interface negotiation as a server-side developer or client-side developer, the bottom line is building new REST APIs for every new project is just a bad idea. So with that, here are some technical resources to support you on your DreamFactory and IoT journey. We're excited to say that we now support MQTT, which will enable developers to build solutions for the Internet of Things. The simplicity and flexibility of this protocol makes it really an ideal choice to build robust IoT solutions, which Jana Kiram is going to talk about today. We actually just published a blog on this new MQTT integration, so be sure to check it out after this webinar. As a quick reminder, you're encouraged to ask questions. To do so, please post in the chat window, and at the end of this session, there will be a dedicated Q&A. So with that, I'm going to pass it over to Jana Kiram now to introduce himself and get this webinar going. Thank you.
Thanks, Alex. It's my pleasure to be a part of this webinar. As Alex mentioned, I'm an architect and an advisor working on microservices and Internet of Things. I've been working closely with DreamFactory in helping them integrate with MQTT and bring the IoT use cases to the already powerful DreamFactory platform. I have about 20 years of experience. Most of that was working for Microsoft. I spent about 11 years at Microsoft, followed by a stint at Amazon Web Services. And since 2012, I have been running my own organization. Currently, I engage with platform companies and IoT companies, helping them with the developer outreach, product strategy, and market research. So I'm going to walk you through the big picture of enterprise IoT architecture, followed by a closer look at what DreamFactory can do to IoT developers and how it tackles the IoT scenarios. And stay tuned for some interesting live demos. So this is not going to be just a presentation, but we'll walk you through live demos of the popular use cases of Internet of Things, where we make devices talk to each other, we enable rules, we visualize the data that's streamed by the sensor. So all of that is lined up towards the end of this presentation. So stay tuned, and we have some interesting things coming up for you. So let's get started with the big picture of IoT. But before that, let me set the stage. Internet of Things is not really a new phenomenon. It's been around for a while. The idea of connecting one device to another has existed for a long time. And when we look back, maybe in 2010, just a few years ago, we had very few connected devices. Maybe our mobile phone was connected to our audio system, and the smart TVs just started becoming popular. The IP-based security and surveillance cameras started streaming. So products like Dropcam, Fitbit, and some of the other connected devices started to appear. But from there to where we are today, we have experienced a sort of explosion in the connected devices. Today, from connected lights, that is smart lighting, to pet tracking, to health monitoring, to sports and fitness, smart homes, smart cities, smart buildings, smart parking lots, whatnot. We are living in an increasingly connected life, connected world, where most of the devices that we deal with are able to talk to each other and providing us value-added capabilities and rich insights. But behind these seemingly simple devices and connected Internet of Things, there is a pretty complex architecture. And if you are a developer, you can relate to a lot of these concepts. So let's take a look at what really goes behind the scenes of Internet of Things. So at a high level, IoT has three layers. The first layer is the devices layer. The second one is the IoT platform. And the third one is basically the applications tier. So this three-tier architecture is not identical to the traditional three-tier architecture. Here, the first tier is the devices that generate the data. The second tier is where the orchestration of the data happens. And the third tier is where the visualization and the command and control goes. So each of these layers form the complex enterprise IoT stack. So we'll understand each of these layers and then look at how DreamFactory aligns with this architecture. So devices are essentially the physical things which could be running in manufacturing units or shop floors or warehouses. They can be deployed anywhere. But IP devices, the devices can be of three types. The first one is the IP capable devices. These are contemporary smart devices that are capable of acquiring an IP address and participate in an Ethernet-based TCP/IP network. So they can directly send the data or receive commands over the network. Then there are some low-powered devices which are based on microcontrollers and very small form factor devices, and they don't have enough power to participate in an IP network. So they use protocols like Bluetooth Low Energy, Zigbee, Z-Wave, and if they're capable, they can even use power on Ethernet. So those are the other type of devices. And then the whole industrial automation phenomenon that's been around for a couple of decades uses protocols like SCADA, RTU, PLC, and telemetry devices. And they have been around for quite some time. So even those devices are now participating in the connected phenomenon. So these are the three types of devices. The IP capable devices make a connection directly to the cloud or the IoT platform, whereas the legacy devices and the non-IP capable devices talk to the platform through a gateway. The gateway acts as a proxy or the edge appliance that essentially connects the non-IP capable devices to the platform. It acts as the true gateway in representing these devices and negotiating the command and control, as well as aggregating the data and sending it over to the IoT platform. So that is the devices layer. Let's understand the gateway. As I mentioned, the gateway can exist in two different places. The gateway that is deployed closer to the devices is going to be responsible for representing the non-IP capable devices to the IoT platform. At the same time, the IoT platform will also run a gateway, which is essentially called as the device gateway, where either the field gateways or the device gateways register with the cloud gateway, and each of those devices get unique identifiers. And these devices are also associated with credentials that are used for authenticating. In a lot of ways, this is like user profile management in a mobile backend. So every device that is participating in the connected solution has to be first registered with the gateway and get the credentials to authorize itself to participate in sending and receiving the data. So the gateway is responsible for authorizing the devices when they connect, when they publish, or when they subscribe. So the authentication happens when the device gets connected with a username, or rather the device name and the token. And every time it publishes, there is a validation of the authorization policy, whether the device is allowed to publish the topic or to the channel or not. And similarly, every time there is a subscription request, the gateway will ensure that the device is authorized to publish and subscribe, or just the subscription policy. At the same time, devices can be whitelisted or blacklisted. When the devices are lost or when they are malfunctioning, they can be automatically blacklisted through the authorization policy. And the moment they get blacklisted, the device gateway will ensure that they don't participate in the solution anymore. The device gateway also manages the device to cloud and cloud to device messages. So typically the IoT platform is going to be deployed in the public cloud for the scale and the extensibility with the big data stack. So the devices typically send the data to the cloud, and they also receive the messages back from the cloud, which will contain some commands that will control the devices. So the device gateway acts as the gatekeeper, making sure that the messages are flowing back and forth. The device gateway ultimately is responsible for exposing protocols like HTTP, which is the standard web protocol, MQTT, which is the low power device centric protocol, AMQP, which is the message queuing protocol based on the pub sub pattern, and WebSockets for real-time streaming of data. Then the next important layer is the data ingestion. So once the devices get hooked onto the gateway, they get authenticated and authorized. The next step is acquiring the data from these devices. And that's where we have the data ingestion layer. So the data ingestion layer is essentially an endpoint for all the devices to stream the high velocity, high throughput data sets. For example, there could be tens of thousands of devices with half a dozen sensors. And each sensor is generating a data point every 5 seconds or every 10 seconds. And the device is responsible for streaming the data to the cloud, and that hits the device ingestion point after the authentication and authorization is done. Typically, the data ingestion endpoint is a one-way communication between the devices and the platform, which means it is exposed as a REST endpoint or an AMQP endpoint. And this is typically used for sending the data originating from the devices to the cloud. Once the data passes through the ingestion layer, it gets stored, and that's where we have a variety of databases. The object storage layer for storing raw data, for example, coming from surveillance cameras or audio sensors or mics, and slightly more structured data, semi-structured data, but that doesn't have a schema, so that goes to NoSQL. And more structured data with an enforced schema goes to a relational database. The storage layer is responsible for storing the incoming data in its raw form, as well as the processed data, which is the output from the data processing pipeline, which we're going to explore. So that acts as the source for querying from various front ends from the application tier. And it's also responsible for delivering the operational insights in the form of query results and reports, dashboards, and so on. It acts as a destination for processing the data set. At the same time, it acts as a source for the raw data, to store the raw data. And typically, the storage is also exposed as a REST API for applications to retrieve the data that is either raw or pre-processed and stored for retrieval. Once data hits the storage layer, it can take one of the two paths. One path is called the hot path analytics. So this is typically responsible for analyzing the data as it comes. It's also called as the stream processing or stream analytics. This is used for querying data as it enters the platform. For example, in a connected car scenario, you might be interested in counting the number of cars that pass through a specific toll gate on a freeway. So that data point is analyzed in real time through a set of services, typically using Apache Spark or Apache Storm or some of the managed services available in the public cloud. So this layer is responsible for transforming, processing, querying, and analyzing the data as it comes, which is typically the streaming data. And it processes each item in the stream at a time, or it can use a sliding time window, which means it can act on micro batches that belong to a specific time window. For example, if I am interested in finding how many cars passed through a toll gate in the last 5 minutes, it's going to perform a micro batch query to find out the number of cars within the 5-minute window. So this is used for finding anomalies of the data that is coming in real time. For example, in a manufacturing plant where the pressure data point and the temperature data point are constantly monitored for any anomalies or the fatal conditions, the hot path analytics pipeline is responsible for finding those anomalies and immediately raising an alert, which might even result in shutting down the malfunctioning equipment. The hot path analytics layer is also responsible for transforming the data from one format to another. For example, the connected car scenario, each car might actually send the GPS coordinates in a latitude longitude format to the hot path analytics layer. And this can call a geospatial service or a geo mapping service like Bing Maps or Google Maps to translate the lat long to a zip code, which is going to be much more readable and much more easy to plot. So the hot path analytics layer is also responsible for transforming the data from one format to another and one protocol to another. Sometimes the data might enter as JSON and it might be converted to other formats like CSV or Avro, which is going to be used by the rest of the big data processing platform. So that's the hot path analytics. Cold path analytics typically collect the data and process them over a period of time. So going back to the connected car scenario, the car fleet company that is managing multiple cabs might be interested in finding out the fuel efficiency of the taxis. But obviously you cannot find the fuel efficiency of a car or a fleet of cars in real time. You got to collect the data of mileage over a period of time, and then you are going to process that to find out which of the cars is more fuel efficient and which path that this car has been taking more often. So that data, which makes sense over a period of time, is typically passed through the cold path analytics. And this is where the data is collected and stored in scalable databases or NoSQL data stores like HBase or Cassandra. And later on, an Apache Hadoop cluster will use MapReduce algorithm for processing that data. So the output from hot path analytics and cold path analytics eventually make it to a business intelligence or a operational insight application, which is going to be visualized by the applications. So the application tier in IoT scenario will perform two jobs or two different tasks. The first one is to show various information, various insights coming from the information generated by the sensors. So you will see those rich dashboards, powerful visualizations, which will instantly give you insights into your data stream. For example, how many cars are currently on the road, how many of them are parked, how many of these cars are going through a specific freeway, how many of them are fully occupied or on hire, how many of them are idle. All of that can be visualized because each connected car is streaming the data that is taking one of the paths, which is either hot path analytics or a cold path analytics. And ultimately the output from these analytics is going to be visualized by the application tier. Apart from that, the application tier is also responsible for sending commands to the connected devices. For example, a shop floor supervisor who is currently away from the manufacturing unit or a manufacturing plant can get alerted when there is an anomaly detected in one of the manufacturing equipments, and the anomaly, if not fixed, can result in a fatal incident. The supervisor can quickly pull up his mobile phone, launch an app, and pause the entire process or even shut down the machine that is malfunctioning. So the application tier is also responsible for sending the commands and controlling the connected devices. And the application tier can also be delivered in multiple form factors. For example, mobile apps running in a variety of mobile devices, wearables with connected fitness devices, watches, and all of that. It's also a very powerful scenario to control the devices from the wearable form factor that an individual is carrying. And of course, web applications, desktop applications, and even television-based applications can be used to send commands to the devices tier. So bottom line, the application tier is used for retrieving and visualizing the data and sending commands to the connected devices. So that is the big picture of the Internet of Things architecture. Now let's shift gears and take a look at DreamFactory. So I have been working on DreamFactory for about 3 years now. We have used it in multiple production applications as well as for prototyping many mobile applications. So traditionally, DreamFactory has been used for mobile, desktop, and web applications. And because DreamFactory uses the universal HTTP protocol for exposing the REST API, it is universally consumed by a variety of applications. Any application that can speak REST can quickly become a consumer of DreamFactory APIs. But Internet of Things don't use REST. As we have seen, some of the devices are not capable enough and are not powerful enough to send HTTP requests or even receive callbacks. So they rely on low power protocols, and one of the most preferred protocol for device-to-device communication or machine-to-machine communication is MQTT. MQTT has been around for a few years, and it is becoming increasingly popular in the IoT segment because of its low footprint, flexibility, and the power of connecting multiple devices using the publishing and subscription pattern. So the first thing that we have done to enable developers to use DreamFactory for IoT is to blend MQTT with REST. And this becomes a very, very powerful combination. So DreamFactory now comes with an integrated open source MQTT broker called Mosca. And this instantly gives developers access to MQTT protocol along with REST. So you get best of both worlds. We have also implemented a device gateway, which means you can register the devices and generate tokens that you can use from the devices to authenticate. And you can also implement authorization for enabling the subscription or publishing process. One of the strengths of DreamFactory is its server-side scripting, and it supports multiple languages, including Node.js, V8, JavaScript, PHP, Python. Other languages are in the pipeline. So one of the important aspects of IoT is a declarative rules engine. Think of it more like an embedded IFTTT, if then this kind of a logic that the developers can quickly implement. The beauty of DreamFactory is every time a data point or rather a record hits the database, it can raise a trigger, not in the form of a native database trigger that you are familiar with, which is supported by relational databases like Oracle, SQL Server, and so on. But this is a server-side script that actually triggers an event. Every time you make a put or a post or a get, you can raise an event and implement a functionality. So this will typically help you validate data before it gets committed to the database. When you combine that with an IoT scenario, it actually becomes a very powerful rules engine. So now you are finding out the data as it comes. Think of it more like the hot path analytics gateway. So even before the data gets committed to a storage backend, you have an opportunity to find the anomaly and raise an alert or a trigger or an action, which can include anything that you can invoke from a REST call. So I'll show you a live demo of this. User management, again, we exploit the inherent capabilities of DreamFactory, which is user profile and user management and role-based access control. So you can create multiple users and associate them with devices, and you can define role-based access control. So which means the devices that are onboarded by a specific user cannot be accessed by other user. So this brings in a multi-tenant security model to the devices connected to the same DreamFactory instance. Beyond that, we also leverage the access to a variety of backends. For example, DreamFactory can be used to interact or interface with object storage like Amazon S3 or Azure storage. So you can actually use that to stream your data to the cloud directly. If you want, you can get the data and store it in any of the supported NoSQL databases that come out of the box with DreamFactory. For more structured data, and if you're using an enterprise version of DreamFactory, you can store it in existing relational databases like SQL Server, Oracle, or DB2. So the choice is available to you in terms of storing the data and ingesting the data. So DreamFactory acts as the ingestion layer, and it out of the box supports MongoDB as the storage for the time series data, but nothing stops you from taking that data and feeding it to any supported storage backend. We have also exposed IoT specific API for machine-to-machine communication using REST, data ingestion, and of course onboarding users, and even sending command and control and data processing. So all of these are extended from the core capabilities of DreamFactory for IoT. So now it's time for me to show you some interesting demos. I'm going to touch upon the top 3 use cases that are very common in Internet of Things. The first one is M2M. So this is basically machine-to-machine communication where we'll make 2 completely isolated machines or devices to talk to each other. Visualization is how you basically visualize the data that is originated from one of the sensors. The third demo that I'm going to show you is how we dynamically control the flow with a rules engine. So it's time for me to show you my current setup. So let me first start with this. I hope you're able to see my lab. I'm actually doing this demo live from my IoT lab, where it's cluttered, but all the devices are here and they just work. So let me show you what I have here. So I have 2 Raspberry Pis. So this is one of the Raspberry Pis. It's actually a Raspberry Pi 3 device with what is called as the Grow Pi Shield, which will make it easy for me to connect switches, actuators, and sensors. So that is connected to LEDs, right? So I have 2 LEDs here. One is the green LED and the other one is a red LED. So this is one of the Raspberry Pi devices. And then I also have another device which is connected to a switch. So if you see, this is a toggle switch. I can turn it on and off. And this Raspberry Pi also comes with a sensor which can track the humidity and temperature of my current environment. So both of them are powered by the USB connector here, but they are not connected. They're actually connected via DreamFactory. So this is going to act as my publisher. This is going to act as my subscriber. So the bulbs will subscribe to the data coming from the publisher. So that is the setup. Now let's look at the software side of things. So I have DreamFactory running here, right? And let me bring up my VirtualBox environment. So I'm running the Bitnami appliance on my local machine. This has got an IP address assigned by my local network. So I'm currently running DreamFactory on my VirtualBox environment. And I have already started the MQTT broker that is front-ending DreamFactory. So if you're seeing some text here, which are the log messages that are coming on my screen, they are basically debug messages from the MQTT broker. And then I have 2 Raspberry Pis. So if you see, this is called RPi sub, and here you see RPi pub. So this is the publisher, this is the subscriber, and this is DreamFactory, which is orchestrating the messages and the data flowing back and forth. So now my first scenario that I want to highlight is basically controlling the bulbs, right? So we're going to add a remote switch to these bulbs. So what I'm going to do now is to launch my publisher first. So I go to my DFIoT folder, into the pub directory, and I launch a simple Python program, and the source code, all of that is available on GitHub. So we will actually share the links to both the blog posts that I have authored as well as the tutorial and the complete source code for these samples. So I'm going to start the button.py, which will connect to my MQTT broker front-ending DreamFactory. So this is the address of my DreamFactory instance. So now I'm going to launch this. Currently it shows 0, which means the switch is in the off state, that is the button. And now I'm going to again do the same steps. I go to the sub directory of my Raspberry Pi and then launch bulb. Sorry, I should also move into this directory, which is button and bulb. And here I have bulb.py. So I'm going to launch this by passing the address of my DreamFactory instance. Okay, now this says just give me a second. Okay, I need to just launch the broker again. Just give me a second. All right, so I'm launching the publisher. This is authenticated and it is able to send the messages. Now I'm going to launch the bulb and now it is subscribed. And since this is coming as 0, this shows off. Now let me switch to my camera. So here is the switch, right, the toggle button, and here are the bulbs. So now what I'm going to do is to just flip this button and immediately the red LED glows, right? And now when we actually take a look at the debug, it shows on and the publisher prints 1, indicating that the toggle state has been turned to 1. So now when I actually turn it off, right, the bulb goes off. Now this might look very trivial. This is not rocket science. This is not very exciting, but the whole idea is these two devices, which are completely independent, are talking to each other over DreamFactory's MQTT capability. So that is the first scenario. There is no limit to what you can achieve with this. This might look very simple, but technically I can replace this button with any other device or any other logic or any other rule that can operate the bulb. So there are many possibilities with machine-to-machine communication. So that is the first demo. Now let's go back and I want to show you one more capability where we now stream the live temperature. So I now launch another Python program called temperature.py, and again I will point this to my DreamFactory instance. And now this is going to stream live data. So 28.0 is basically the temperature in Celsius of my room, and 32 represents the percentage of humidity. Now what I'm going to do is to subscribe to this, but before I do that, I want to switch to my browser and show you a quick tour of DreamFactory. So now I log into DreamFactory and I click on, if you're already familiar with DreamFactory, you will find this something that you're already familiar with, something that you have been experienced with. So first thing is, when we look at services, we added a few services. For example, there is a device registry service, there is a telemetry service, and there is a messages service. So all these services are very specific to DreamFactory's IoT. And when you run a script, all these services get added, and they are used for registering the devices, sending the telemetry data, passing the messages between the devices. So once you have all these in place, and once your data is getting streamed, which our sensors are doing now. By the way, this is the temperature sensor, which is responsible for streaming the data. So now what I'm going to do is launch another application, which is an open source visualization tool called Freeboard. And this Freeboard typically expects you to add certain parameters and REST API endpoints for it to pull the data and set up the visualization. So as a part of DreamFactory IoT setup, we pre-populate the file section with the freeboard configuration data. So now you can actually download this dashboard.json, which gets downloaded to my folder locally. And then I click on load dashboard, navigate to my downloaded file, and I select that. And now you actually see a real-time dashboard of the data coming from the sensors. So if you are actually not convinced that this is real data, let's look at the temperature. It is 28 and humidity is 32. That's the reason why it is always a flat line here, a sparkle line. Now what I'm going to do is to emulate some increase in humidity and temperature. So what I'm going to do for that is just hold the sensor. So when I actually hold it tight, I increase the humidity and temperature. So let me hold this and switch back. You'll actually notice that gradually the humidity and temperature increase, right? So any change in this, there we go. So 33, and slowly it will increase. The temperature has gone to 29, and so will be humidity in a few minutes. So this is basically changing the temperature and humidity forcefully, right? So now let's go back to the visualization, and there you actually notice that there is a jump in humidity from 32 to 33, and it has gone further to 34. And you'll also see the dial changing here from 27, 28, and it's going up to 30. So this is currently showing the temperature as a dial, and the sparkle line represents the humidity. And trust me, getting to this point is fairly simple and straightforward. We have completely documented all these steps for you, and this is very extensible. It's open source, it's extensible, and you can customize this completely. So now I'm still forcing the temperature and humidity to raise. I'm going to leave this. I'm going to, I have dropped off the sensor, so it is now back to the normal state, and you'll see that the humidity is slowly coming back to the normal, and that will reflect in our real-time dashboard. So you will see that in a few seconds this will stabilize. So now it has touched 32, and 32 is the typical humidity in this room, and you'll also notice the temperature gradually dropping and hitting 27, 28. So this is actually the visualization aspect of Internet of Things, and Freeboard is an open source add-on that we integrated with DreamFactory for you to go ahead and customize. So that is the second demo, where we are seeing how we are visualizing the data coming from the sensors, the live sensors. All right, that's not all. I have one more demo for you, where I want to control the color of the bulb based on the temperature. So now if you actually look at these two bulbs, they are not on. They're currently switched off, they're not glowing. What I'm going to do is to run a subscriber which is going to control the color of the bulb based on the humidity. So I will launch the temperature client. Sorry, this is bulb.py with the address of my DreamFactory instance. So when I run this, you will immediately see the color of the bulb changing to green. So that is green, right? That's because the current humidity is under the threshold that I have maintained. But where do I define this rule? Well, it's pretty straightforward. I go to Scripts tab of DreamFactory, and then you notice that there is a table called Telemetry. I select that, the service, and I select the telemetry table. And for the post request and the post process, there's actually a server-side script. So this is currently controlling how my environment indicator works, right? For example, here if you see the, if you notice the humidity, as long as it is less than 40, the color of the bulb is turning green. The moment it is more than 40, we are turning this to red. So this is the rule that I have used, and if the rule is met, this payload, where I'm changing the color, is posted to this endpoint, which is actually a HTTP endpoint for publishing to the topic. So that means this dfiot/temp is the same location where my subscriber is currently listening. That means every time we send the data, which is the payload, the JSON payload that contains color is green or color is red, my subscriber will automatically receive and immediately changes the color. This can be completely customized. For example, I can make a call to Twilio to send an SMS, right? Or even a VoIP call. I can actually make a VoIP call to a supervisor or to the point of contact to let them know that the humidity has increased. I can use Amazon SNS to send a message, right? And that message can trigger anything. So anything that can act upon the REST call can be invoked from this rule, and it's a very powerful concept. So currently the humidity is less than 40. If you see, it's always hovering between 30 and 35. So that's the reason why it's always green. But let's go ahead and turn this to 30. So now I turn this to 30 and click on save, and immediately when I take you to the setup there, you notice that the color of the bulb has changed to red. Okay, that's because I have changed the threshold to 30. Now let's try this one more time. Now I come back and I revert back to 40. Click on save, and the moment I switch, even before I switch my screens, the bulb turns green. So that's a very, very cool way of controlling your devices based on a specific rule. And this rule in DreamFactory can be written using any of the supported languages: Node.js, PHP, Python, or V8 JavaScript, with new languages coming in the future. So that's the whole idea of bringing IoT to DreamFactory. Now let me take you back to my slide deck and show you the big picture of IoT. Devices, they are IP capable and non-IP capable, which will talk via the local gateway to the device gateway. And once the devices get authenticated and authorized, they start ingesting the data, and the data can get stored before it goes through stream processing for hot path analytics, batch processing for cold path analytics, and finally it gets visualized in the application tier through one of the applications. And we can also command and send and control the devices from the application tier. And we have seen all these things happen from DreamFactory. Since DreamFactory supports multiple backends, the stream processing and batch processing is pretty much left to the data sources. But DreamFactory can act as the device gateway, it can act as the ingestion layer, it can act as the device registry, the user management layer, and it can perform all the functions that we have discussed in the big picture of IoT. So that brings us to the end of this presentation. At this point, I will hand it over to Alex, and between us, we will handle any of the questions that we may have seen.
Yes, thank you so much, John and Kiram. So we'll now move to QA. It doesn't seem like we have any questions right now from the attendees, so feel free to send those in. And you can do so by going into the chat window and posting them. And feel free to do so now. So Johnny, back to you. And if
Excellent.
there's other questions, we could always end early.
Absolutely. So I want to leave you with the blog post that is already on dreamfactory.com. So go to the resources, go to the blog, and look up for this blog post on DreamFactory for IoT, and that explains our motivation behind bringing MQTT to DreamFactory. I also strongly encourage you to check out the DF IoT repo on DreamFactory's GitHub that has all the required scripts and the sample code that I have shown you. You can set up 2 Raspberry Pis, attach the sensors, and run the sample all by yourself to experience the same demo. If you have any questions, you always have the forums. Feel free to drop a question at the DreamFactory community forums, and the moderators will definitely respond to you. And if you have questions for me specifically on IoT or DreamFactory integration, you can always reach me through janakiram.com, or I am on Twitter at janakiram, and I look forward to interacting with you. Thanks again for joining. I had lots of fun demonstrating, and I hope you had fun too.
Yeah,
Have a
thank you
great day
very
ahead. Thank
much.
you.
Have a great day.